Hello, this is Ms. DB, and in this video we are going to write a lot of proofs. We are going to learn about Chapter 4, Section 6 on triangle congruence, especially on CPCTC, which is fun to say and means corresponding parts of congruent triangles are congruent. You should have read this section in your book first or watched the longer video. In the longer video I do the proof for number 7 in that video, so we're not going to do it in here, but you can go back and look if you need to. Alright, so the first few questions are just we're dealing with what is CPCTC, which you can certainly look back at. And then in number 2, it says we're going to use that. We're going to name the triangle congruence postulate or theorem that shows that these two triangles are congruent. So that means to pick from one of these. And then once you pick the right one, then we can use CPCTC, corresponding parts of congruent triangles are congruent, to name the other 3 pairs of congruent parts. So we won't name the parts that are already marked congruent. Angle B is already marked congruent to E, so we're not going to use that one. We need to use something like, we already have this. Oh, we don't have angle A and angle D. But if you prove that these two triangles are congruent by one of these things, then we can say that angle A is congruent to its corresponding angle in the other triangle, which would be angle D by CPCTC. And we can also prove, well, let's see, we already know that AB is congruent to DE, but we could use CPCTC to say that AC, oh, I'm writing in too big of a, AC is congruent to DF. This is supposed to be angle A here and angle congruent to angle D here. And then you can find the other pair, the other side as well, that you could say would be congruent now that you know that the two triangles are congruent. So in CPCTC, we don't use it unless we know the two triangles are congruent. If we know the two triangles are congruent, then we can use CPCTC to prove that the other parts that aren't marked congruent are also congruent. So first in number 3 as well, you have to say, how do we know that these two triangles are congruent? So you need to figure it out. And you might use things like vertical angles or reflexive property in order to find something that's not marked is congruent. So in this one, we can say that, I think that's an I in the middle, that angle JIK is congruent to angle HIG. So since those two angles are congruent, I can use angle, side, angle, angle, side, angle. Angle, side, angle proves that these two angles are congruent. And then I can, now that I know they're congruent, I can use CPCTC to find the width of GH. That's how wide the river is right there. So this side is equal to what other side, which is marked, and then you can know that they're congruent, so their lengths will be the same. All right, now we're going to look at proof. So in order to prove, or in order to use CPCTC, you first have to have congruent triangles. So that's your first task, is to get congruent triangles. You use the given information. You look for vertical angles, reflexive property, things like that, to find another either pair of congruent sides or pair of congruent angles. And then after that, you use SSS or SAS or angle side angle or any of those things that we've learned about in the last 2 sections to prove that you have congruent triangles. Once you prove that you have congruent triangles, then you can use CPCTC as a reason in your proof for the other angles being congruent or the other sides being congruent, those that were not given. So this is an example. You can look over that one. And then let's look at how to do number 5. So again, we are going to first prove that the two triangles are congruent. So let's look at our two triangles. It looks like we're going to be dealing with triangle PQS and triangle RQS. And I can see that there's already a side marked congruent in each of them and an angle marked congruent in each of them. And in fact, if we look over at the given, that's what they give us. Side PQ is congruent to side RQ, and angle PQS, which is this one up here, is marked congruent to RQS. So our given is already filled in for us. Now, the big giant hint is that we next need to use the reflexive property. The reflexive property says that if you share a side or share an angle sometimes, then you can use the reflexive property to say that it is congruent to itself. And that's what we have. We have that side QS is congruent to side QS because of the reflexive property. And that both of those triangles share that side, so we need a third thing. We've already got a side and an angle. Now we have a side and an angle and another side. So now you're ready to write what two triangles are congruent to each other. We have triangle PQS. Make sure you put the right letters in here. So PQ, that's the side that's marked with one tick mark. So I need to name, when I do my second triangle, I want RQ to be listed first. RQ, and then down to S. And the reason is SAS. And finally, they want us to prove that angle P over here would be congruent to angle R over here. And now finally we're able to do that because we've already proven that the two triangles are congruent. So then by CPCTC, we can say that those two angles are congruent to each other. So now you try number 6. In number 6, the statements are all here, and you need to name the reasons. So some of these might be given, some of them might be reflexive property, and then when you get to step 4, when you have that one triangle is congruent to another triangle, you need to decide, is that because of SSS? Is it because of SAS? Whoops, I suddenly was stopped writing. Is it because of HL? Is it because of... You got to figure out what is the reason that I'm able to say that, and then from there, you're able to use CPCTC after that, after you prove that the two triangles are congruent. SSS is not the one you'll use. I'm trying to delete this, but it's acting weird on me now. So you pick the correct one from all of the postulates and theorems that we learned about in 4.4 and in 4.5. You can use any of those. And then, like I said, I actually proved number 7 in the other video, the longer video, so you can go back and check that out if you need any help, if you get stuck. And then the last section on here, let's talk about this. This is using CPC in the coordinate plane. So we've talked a little bit about coordinate proof before, and we will continue to do so, but what we're going to do is they'll give us some points, plot those. Now, I highly recommend that you put them into Sketchpad because Sketchpad has tools to measure the lengths of segments, so that could be really handy. If you're not going to use Sketchpad, then you need to use the distance formula to find the lengths between 2 points, the lengths of one of the segments. When you do that, if you're going to be able to use like side, 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 you'll find that there's lots of equal lengths, like square root of 10 and the square root of 10. AC is congruent to DF. AC is congruent to DF. Those two sides of the triangle are congruent. Also, BC is congruent to EF. BC is congruent to EF. And then also AB and DE were both 5. So they found that by side, 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 these two triangles were congruent. Now they want us to find out if angle ABC, that's this angle right here, if angle ABC is congruent to angle DEF, that's this angle. Well, because they're in corresponding locations, they're both the angle between the sides marked with 3 and 2 tick marks, and they are congruent triangles, therefore by CPCTC, these two angles are congruent. So that's what you're going to do on number 8. You are going to decide whether you want to use SSS, SAS, or any of these. Now, you may be able to use SAS if you could show that these two lines, RQ and SQ, are perpendicular. Then you would have that this angle, and then you would just need this side and this side. Or, if you do have right angles, you could use HL. You could show that one of the legs and the hypotenuse is congruent to one of the legs in the hypotenuse. So it all kind of depends on if these two are actually perpendicular. Well, how do we know if they're perpendicular? They're perpendicular if their slopes are opposite reciprocals. Let's find the slope of RQ. I'm going to make a slope triangle, and I'm going to do rise over run. It looks like the slope of RQ is -3 over 2. Down 3 and over 2, and it's going downhill. Now let's compare that to the slope of R or QS, this one. Now if that's 2/3, then this is a perpendicular, these two lines are perpendicular and this is a right angle, but I'm not sure if it is yet. So let's look at QS. Its slope would be, let's do a slope triangle. Let's go all the way over just so I don't mess anything up. The rise is 1, 2, 3. And the run is 1, 2, 3, 4, 5. Yeah, these are not perpendicular. These two slopes are not opposite reciprocals. Therefore, these are not perpendicular lines. And I'm not going to be able to use SAS or HL to solve these triangles. 1, 2, 3, 1, nope. 1, 2, 3. It's so close, but not quite. So then I'm going to try to do these with SSS then. And SSS means that I need to find the lengths of each pair of segments. So there's a lot of work to do here. So I have to find the distance between R and Q so that I can find the length of RQ. So it's equal to the square root of, let's see, R is at -4, 1, 2, 3, 4, and Q is at -2, 1. So for the distance between those points, you take the difference in the x-coordinates, which would be -4 minus a -2, and square it. And then to that we'll add the difference in the y-coordinates, which would be 4 minus 1, and square that. And then we'll do this math, and we'll get -4 minus a -2 is the same as -4 plus 2. That's -2. So -2 squared plus 4 minus 1 is 3 squared. So -2 squared is 4 plus 3 squared is 9. So we get the square root of 13 for this one. And then you can either do the side that you think will match it, WX, let's do that, and see if we get the same thing, and then we'll have one pair of corresponding sides being congruent. So for WX, my difference in my x-coordinates, let's see, this one is 1, -1, and this one is 3, -3. So I am going to take and put the difference in the x-coordinates would be 1 minus 3, and I need to square that, and the difference in the y-coordinates would be -1 minus -3. Square that. Okay, so 1 minus 3 is equal to -2, so I have -2 squared, plus, I'm just double checking that I wrote this right. Oh, this is actually at 4, sorry. That's going to matter because 1 minus 4, so this should have been -3 squared. And then the other one is correct. So this would be -1 plus 3. -1 plus 3 is 2 squared. So that would be 9 plus 4, and the square root of that would be square root of 13. So these are equal. So I know that I have one pair of corresponding sides. And then you would repeat that for RS and QS and X, Y, and WY. But there is a shortcut, a little bit of a shortcut, because RS is a straight horizontal line. I just have to count how far over it is. 1, 2, 3, 4, 5, 6, 7. This is 7. 1, 2, 3, 4, 5, 6, 7. And this is 7. So I've already found out that these two sides are congruent. So then you just have one more pair of sides to do the distributive property with. And not the distributive property, the distance formula, which is given right here. and finish that up, and then it will probably be the same, and then you'll have side, 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 and you'll write down all your pairs of congruent sides, and we don't need to use this step or this step because we didn't find congruent angles. And then just explain, did we use SSS or SAS or HL? We used SSS. And then finally, if you know that the two triangles are congruent, then you can use CPCTC to show that their corresponding angles are congruent. All right, that's it. Have a wonderful day, and let me know if you need any help.